Okay, so I know you can barely see this, but bear with me. Last semester, we learned about a parent function y is equal to 1 over x. That's called a rational function. Remember that? Yeah, and then if you're in my class, we did the, you can't really show me, the sign, with the hand, well, you can't really see. Rational function can also have x in the numerator and the denominator. Today, we'll look at the graphs of this type of the rational function. So really, this lesson is about learning about the features of what rational functions are and then be able to relate that with the expression algebraically. Okay? So, right there, graph the function y is equal to x plus 1 over x minus 2 using Desmos. I already did that for you right there, x plus 1 over x minus 2. So as you can see, there are two wings going on, one on the left bottom over here, one on the right tab over here, which what you're going to graph on your graph to the right side. So for me, it kind of looks like there are two asymptotes going on. There is a vertical asymptote going on at x equal 2, so let's go ahead and draw our asymptote at x equal 2, as well as kind of looks like y is equal to 1, y is equal to 1, and the points, just guess it, okay? So 4 comma, like 2 point something, so up here, and 2.5 comma 4. Okay, and then just go ahead and draw your right hand top corner. The left bottom's points can be like 1 comma negative 2, negative 2 comma like 0.5. Okay, I think those are two good points. Let's go ahead and connect them right there. Okay, so did you graph that? Just like what you see on the Desmos. All right, it says what value makes the numerator equal to 0? Sorry, you can't see. Label this value on the graph. So what is the numerator? X plus 1. So I'm going to go ahead and set x plus 1 equal to 0. Subtract 1 to both sides. X is equal to negative 1 is what makes my numerator equal to 0. Label this value on the graph. So when you look at the graph, when x is negative 1, I'm clicking x equal negative 1. You see that right there? What's the y value? 0. 0. So let's label that. Negative 1 comma 0. Right there. Negative 1 comma 0. Sorry, you can't see. Negative 1 comma 0. All right, next, what makes your numerator equal to 0? Denominator equal to 0, excuse me. X minus 2 is equal to 0. Add 2. X is equal to 2. So when you look at the graph, what happens at x is equal to 2? It's what's happening here? Asymptote. What kind of asymptote? The vertical asymptote. So I already marked that, but let me just mark it again. At x equal 2, I have a vertical asymptote. So vertical asymptote. What happened at negative 1? The one we just did it. That was the 0 of the function, so x-intercept. Okay? Alright, this is just the investigation over here. Now it says graph the function using Desmos. Okay, I'm going to pause it and do it and come back. Alright, so I did that on the Desmos, the weird looking one. Guess I should graph that, shouldn't I? Looks like there is a vertical asymptote at x equal negative 2 and x equal 2. Negative 2, so I'm going to draw my dotted line at x equal negative 2 and x equal 2. Are you all with me? And 0 comma 3 comma 0 with the going that way, kind of going that way. Oops. And then the middle section, 0 comma something, and then something, like that. Right, and then the left corner, negative 4 comma 1.5. Something looks like this over here on the left hand. There you go. There's just my sketch of what I see on the Desmos. Letter A, what value makes the numerator equal to 0? My numerator is x plus 1, x minus 3. So let's set that equal to 0. I get x is equal to negative 1. I get x is equal to 3. And tell me what happened at x equal -1 and x equal 3. At -1, y value is 0. At 3, y value is 0. So right there, what happened? These are the x-intercept. Cool. Alright, what makes my denominator equal to 0 then? X minus 2 equal to 0, x is equal to 2. X plus 2 equal to 0, x is equal to -2. What happened at 2 and -2? -2 and 2, what are those? Vertical asymptote. So kind of same thing happened as the previous example, right? When you set the numerator equal to 0, both gave you the x-intercept. When you set the denominator equal to 0, both gave you the vertical asymptote. What does numerator tell us about the graph of a function? So let's write down the summary of it. The 0 of the numerator gives the x-intercept. Gives x-intercept. So when you set your numerator equal to 0, it gives you the x-intercept. Next, what about the denominator? When you set the denominator equal to 0, what happened? Those gave you the vertical asymptote. The denominator, the bottom one, gives vertical asymptote. Cool? Okay. You know what? I don't think I need the graph anymore. So let's go back to the whole screen. There you go. Use the function, identify the x-intercept. So without the graph, you should just be able to find what x-intercepts are, what vertical asymptotes are, just from the equation of the function. So how do you find the x-intercept? X-intercept is found by set zeros of the numerator, right? 0 of numerator. So what is my numerator? X plus 5. X minus 3, both equal to 0. I get x is equal to -5. X is equal to 3. How do you find the vertical asymptote? Zeros of the denominator. X minus 3 is equal to 0. X is 3. X minus 1 equal to 0. X is 1. Graph the equation. Are the x-intercept and vertical asymptote where you expected them? Explain. Okay, so I guess I have to go back to the thing. All right, there you go. So let's retype it. We do x plus 5, x minus 3, x minus 3, and x plus x minus 1. All right, there's my graph. Can you see? Okay, so using this graph, let's see. We said zeros are at -5 and 3. At -5, do you have 0? Yep. What about at 3? At 3. Oh, right there. Wow, I can't stop. Right there. Oh. Right. Oh my word. Right. Right there. What does it say? 3, undefined. And what kind of circle is there? It's the open circle. So folks, remember over here we says x equal 3 on your note. X equal 3 is going to be x-intercept, and x equal 3 is a vertical asymptote. But actual on the graph, what happened there? It's the open circle with undefined. So let's write it down. No. At x equal 3, there is a hole. We're going to call that a hole. When there's an open circle on the graph, we're going to call that a hole. Well, I can't go back. Right there. And why did that happen? Why did that happen? Because, do you notice that x equal -3 is both on the numerator and the denominator? Yeah, so that actually cancels out. So that's another thing I want you to add it, is that if there's a canceling factor of the numerator and the denominator, meaning if you can cancel it out, what will that look like on the graph? That's going to give you the whole. Got it? Cool. Let's summarize that on the next page. Next page, the keynotes. Key features of the graphs of the rational function. Oh, we're going to write a lot. Are you ready? Okay, so for the rational function, there are three things going on. Zeros of the numerator. So the top one, when you set the top one equal to 0, what does that give you? It gives you the x-intercept of the rational function. Why? Why would that be? Because if numerator is equal to 0, then the whole function is 0. Folks, think about it. What is 0 divided by 4? 0. What's 0 divided by 5? 0. So when your numerator is equal to 0, the whole thing becomes 0. That's why it gives you the x-intercept. Got it? Alright, what about zeros of denominator? What happened when you set your denominator equal to 0? It gave you the vertical asymptotes. Why would that be? Why? Because if denominator is equal to 0, it doesn't exist. Right? Like, think about it. What is 3 divided by 0? Remember, math commandment number 1 is thou shalt not divide by 0? Yeah. It's undefined. There's nothing there. Cool. Alright, now the third thing that we just added was 0 in both numerator and denominator. There was a hole. Another way to say that it was the canceling factor of denominator and numerator. Why? Because we can't have x-intercept and asymptote at the same time. Can have, because it's like both of them, right? So, but we can have x-intercept and asymptote at the same time. But it does not exist, it should not exist, so we're just going to make a hole there. Cool? Alright, let's go. Identify any x-intercept, holes, asymptote out the graph of that. So first thing you have to do is make sure you factor everything so that it's in factored form. Does that sound familiar? Yeah, we just did that on the previous page. So top is the ACB, bottom is the ACB. You're going to get x minus 3, x plus 1 over x plus 4, x plus 2. Aha! Alright, how do you find the x-intercept? It's the numerator equal to 0, right? So x minus 3 equal to 0, x plus 1 equal to 0. I get 3, I get negative 1. How do you find the vertical asymptote? Denominator equal to 0. With the following. Folks, was there anything that's canceling top and the bottom, both of them? Nope. So what does that mean? No hole. No hole. Let's go. Next. Factor everything. Is it already factored? Yes, it is. Now, as soon as you see it, do you see something is canceling? Yeah. What's the canceling factor of the top and the bottom? X minus 5. Do you see that? So since it's canceling, what would that make it? What would that become? The whole, right? So x is 5 is the whole. Okay. Alright, what about the x-intercept? X-intercept is the numerator equal to 0, but there's nothing left, right? Because that becomes a whole, so there's no x-intercept. What about the asymptote? My denominator equal to 0. I already used x minus 5. So I have a x equal negative 1, y-intercept. Vertical asymptote. Very good job. Good job.